if we think back to our old motion formula where velocity is equal to the distance travelled over the time taken, we can use this formula to rearrange and calculate a speed or a velocity of a wave. So if the distance travelled in a wave example, what would that be? It would be the wavelength. So how far one wave travels, if it does a full loop from start to finish, it would tell us the lambda, right? So this distance here, from here to here, is our lambda. That's our distance. Time, how long it takes, would just be the time from here to here. And it would be over time, or the period, time it takes for that wave to travel. Distance over time. Time is period, distance is wavelength. But one thing to know is that the period is equal to 1 over the frequency. So therefore, if we look at this equation, I've got V is equal to lambda times, and this is 1 over t, so this is 1 over t. All I've done is I've split these two fractions. Now this is the same as lambda over 1, but 1 over t is equal to lambda over 1 times 1 over frequency. And anytime you see this, a 1 over f, you can just flip the bottom and put it on the top. So this thing becomes up here, and it all becomes over 1. So therefore it gives you lambda times frequency. And this is velocity. So this is very important. This is your wave equation. V equals F lambda. It's an extremely important and very powerful formula to use in the waves. This tells us that for any wave, if I know its frequency and either its velocity or its wavelength, I can calculate the other unknown. So I could give you its wavelength, let's say lambda equaled 2 meters, and its velocity was, for the sake of making the math easy, 4 meters per second. The question would then be, well, what is its frequency? How many times per second would a wave that's 2 meters tall and moving at 4 meters per second be? We can use this equation and just plug in V equals F lambda. F I don't know, lambda I do, and V I do. So 4 is equal to F times my lambda is 2 meters. Divide by 2, I get 4 divided by 2 is equal to frequency, which will be 2. Important to note here, and we know that the units are hertz, but they're also per second, and you can see this here. I had 4 divided by 2, but what was velocity was meters per second. So if I look at the units, it's meters per second equals frequency times meters. Therefore, if I divide by meters, which I've done here, and move this over here, I get meters per second divided by meters equals frequency. And the meters will cancel out. I get per second. So frequency is just equal to per second, which makes sense because a hertz is how many cycles travel per second. So the unit is just equivalent to